In this lesson, we're going to find the domain and range from a graph. It's very important that you remember the difference between domain and range while you're doing this. So remember from our last lesson that domain is your x values and range is your y values. On a graph, domain is the x-axis, which is the horizontal axis. So everything we do today with domain, we're going to go from the left to the right. And then range is your y-axis or your vertical axis. So for range, everything we do is going to go from the bottom to the top. Another thing that you have to remember today is our vertical line test, because we're also going to determine if each graph is a function or not. So let's start with number 1. And what I want you to do is write next to this one the word discrete. This is a vocabulary word from our last lesson. Remember, discrete functions are disconnected. They are not connected. When you have a discrete graph like this one, where it looks like just a bunch of points, I highly recommend making a table. And what you're going to do first is you're going to look at each point. So starting on the very left, I'm going to name this coordinate -3, +3. My second coordinate is placed at -2, +2. My third coordinate is at the origin, or 0, 0. My fourth coordinate is at 2, 0. And finally, my last coordinate is at 1, 2, 3, 4, -2. Once you've listed all of your points, the x values are representing your domain. So just like last time, we're going to list them from least to greatest. I have -3, -2, 0, 2, and 4. And then the y values are representing your range. So from least to greatest, I have -2, 0. Even though 0 repeats, you'd only have to write it once. 2, and then 3. The last thing we're going to do is decide if this is a function or not. So there's two different ways you can do this. First, you can look at the graph and see if it passes the vertical line test, or you can look at the table that we made and you can see if x repeated or not. On this specific graph, x does not repeat, so this is yes, a function. It's a good idea to pause the video and try number 2 on your own before we go through it together. Checking number 2. Number 2 is also a discrete graph. So I would start by making your table. When you look at this, my first point on the left is -1, 2, 3, 4, +4. My next point is at -2, 3. Be careful with your signs here. Then I have -2, 1. My next point is at 0, -2. Then I have 1, 2, 3, -3. And I have 5, -5. First, I'm going to look at my x values, which remember that represents your domain. So I'm going to list from least to greatest: -4, -2, 0, 3, and 5. For my y values, from least to greatest, I have -5, -3, -2, 1, 3, and 4. And then to determine if this is a function, you can look at the graph and the table. Looking at the graph, the vertical line test fails right here at -2. Also looking at the table, x repeats at -2. I have -2, 3, and -2, 1. Since those are different y values, this is not a function. Now let's move on to some continuous functions. Starting with number 3. Number 3 is a continuous function. It is a diagonal line with arrows, meaning that it's going to go on forever and ever and ever. So when you're looking at continuous functions, we're first going to look at the domain, which remember is your x-axis. So what I'm going to do is I'm going to draw the x-axis above my graph. If you look at this, the arrow right here is telling me that this graph is going down and left forever. So from left to right, this graph is going left forever. The arrow on the top right, going up and right, tells me that this graph goes right forever. Since this graph has arrows going left and right forever, we are going to call our domain all real numbers. And if you want, you can use the symbol for all real numbers. It is a capital R with 2 lines. Now looking at the range. The range is very similar, except your range is your y-axis, so you're looking from the bottom to the top. Since I have an arrow going down forever, and I have an arrow that's going up forever, my range for this graph is also all real numbers. Now, looking at this for the vertical line test, you can use your pencil or you can use your finger. This function never crosses a vertical line more than once, so this is a function. Go ahead and pause the video and try number 4 on your own, and then we'll work through it together. On this one, the arrow on the top left is telling me that this graph from left to right is going left forever. The arrow in the bottom right tells me that this graph is going right forever. So again, my domain for this diagonal line is all real numbers. For my range, I have an arrow that's going down forever. I have an arrow that's going up forever. So my range is also all real numbers. This function passes the vertical line test, so it is a function. Moving on to number 5. Number 5 is very similar, except this time you have a horizontal line, and we're looking at this line right here. So, looking at this line, we're first going to talk about the domain, and so we're going to look at how this graph moves from the left to the right. This arrow tells me that this graph is going to go left forever. This arrow tells me that the graph is going to go right forever. So, since I go in both directions forever and ever, my domain is again all real numbers. But let's talk about the range. The range is a little bit different on this one. If you look at the range on this one, we're looking at how the graph moves from the bottom to the top. Well, this graph actually never moves from the bottom to the top. If you look, your y value is always in the same place. I have 0, 2, I have 2, 2, I have 5, 2, I have negative 3, 2, and so on. In this case, your y value is always 2. So for your range, you are going to write y equals 2. Be careful on this. Make sure you're using y and not x, because remember, range is always y, domain is always x. For our vertical line test, this crosses once through every vertical line, it passes, so this is a function. Let's go ahead and skip to number 7 and compare the two. 5 was a horizontal line, and if you look at 7, it's very similar, except now you have a vertical line. So let's see the difference between the two. For your domain on number 7, if you look at this, our vertical line never moves left and it never moves right. Instead, my x value is always in the same spot. It's always at 4. So my domain for this one is x equals 4. It never moves away from 4 for x. For my range, this arrow is telling me that I'm going down forever, and this arrow is telling me that I'm going up forever. So my range for this vertical line is all real numbers. If I were to draw a vertical line where my line is, it is crossing this vertical line over and over and over again. Since x repeats over and over and over, this is considered not a function. It fails the vertical line test. So look at 5 and 7, look at the domain, range, and function, and see the similarities and differences. If you look very carefully, you can see that they are opposites of each other. For a horizontal line, your domain will be all real numbers. For a vertical line, your range will be all real numbers. For a horizontal line on number 5, your range is y equals 2. And for the vertical line on number 7, your domain is x equals 4. So they're kind of opposites of each other. Knowing this, try number 6. Oops, there's 2 number 6s. Try both number 6s, and then we will check it. Pause the video and then restart once you're ready. All right, on number 6, I am going left forever. I am going right forever. So my domain is all real numbers. For my range, I am always at positive 3 for y. So y equals 3. This is a function because it passes the vertical line test. Your other number 6 with the vertical line, for my domain, I never move left, I never move right. Instead, I am always at 2. So my domain is x equals 2. For my range, if you look carefully, I am moving down forever, I am moving up forever. So my range is all real numbers. This does not pass the vertical line test, so it is not a function. Let's move on to number 8. On number 8, you have a shape, it's a U shape, and it is called a parabola. We will talk more about parabolas in the second semester. They are an example of a quadratic function. So one misconception with parabolas is a lot of people assume that it is moving straight up here. But actually, parabolas are curving very slightly and moving out. So even though it looks like it's going straight up, this parabola is getting wider and wider and wider. This is important because when you look at your domain, it does not start and stop. It's getting wider and wider and wider. So it's going to end up going left forever, and it's going to go right forever. So for this parabola, my domain is all real numbers. Now let's look at the range. The range is a little bit different from what we've looked at before. If you look at this, remember we're going to look from the bottom to the top. So on the bottom, I am starting for this parabola when y is 1. Then these arrows tell me that this parabola is going to go up forever. It's never going to stop. So in order to represent this, we are going to write this as an inequality. So since y is going up your y values get bigger as you go up. We are going to write this as y, we use y because it's range, is greater than, because it's getting bigger, or equal to 1. I underline my inequality because this is a solid circle here. If that had been an open circle, then I would not underline my inequality. Finally, I need to decide if this is a function or not. So, since this is getting wider and wider, it looks like it wouldn't pass the vertical line test right here, but it actually does only cross once at each vertical line. So, this is yes, a function. Pause the video, try number 9, and restart when you're ready to check. All right, for number 9, this parabola is getting wider and wider. So it's going to go left forever, it's going to go right forever, which means that my domain is all real numbers. For my range, I am starting where y is negative 1, 2, 3, 4, and then I am moving up forever. So my range is y is greater than or equal to negative 4. This does pass the vertical line test, so it is considered a function. Number 10 is almost the exact same as 8 and 9, except now instead of it being a parabola, you have a V shape. This is an absolute value function. You'll see this later on, again in one of your math classes. But it's pretty much the same concept. If you look at your domain, I'm looking at how it moves to the left, and I'm looking at how it moves to the right. So this arrow right here tells me I'm going to go left forever. This arrow right here tells me I'm going to go right forever, which means my domain is all real numbers. For my range, I'm looking from the bottom to the top. So those arrows tell me I'm going to move down forever. But then what's interesting here is it doesn't move up forever. It actually stops at this point, which is where y is 0. So to write this for an inequality, we're going to say y is less than or equal to 0. I'm choosing less than because it is going down. Before we used greater than because it was moving up. This one's going down, so we use less than. I went ahead and underlined my inequality because I don't have an open circle at 0. It can equal 0. And then finally, this is a function because it passes the vertical line test. Number 11 is very similar to what we were just talking about, except now if you look, this parabola is turned on its side. This changes things a little bit. So if you look at the domain, first we're going to look at how it moves from the left to the right. This parabola starts on the left at positive 2, and then these arrows tell you that you are moving right forever. Since we are talking about domain, we're going to use x. X's get bigger as you move to the right, so x is greater than or equal to 2. For my range, since this parabola is getting wider and wider, that means that eventually this parabola is going to go down forever, it's going to go up forever, which we now know means that my range is all real numbers. Now, this one does not pass the vertical line test. If you look here, it crosses a vertical line more than once. So this is not a function. All right, on number 12, we have what we call a ray. So it starts at a point and then it moves in one direction forever. So again, we're just going to break this down between domain and range. So first, looking at domain, you're only looking at how it moves from the left to the right. So for this specific graph, I am starting on the left at -4. And it's very important to notice that that is an open circle at -4. Then this arrow tells me that it's going to eventually move right forever. For my range, I'm starting on the bottom at -2. Remember, that's an open circle. And then this arrow tells me that I'm moving up forever. So we're going to write inequalities for each of these. First, looking at our domain. My domain is moving right forever, and we know that x values get bigger as you move to the right. So for my domain, I am going to say x is greater than -4. I do not underline the inequality sign because this is an open circle. It cannot equal -4. I used greater than because it's moving to the right. Now for my range, I'm going to say y is greater than -2. Again, I did not underline my inequality sign because this is an open circle. I used greater than because it's moving up, and up means they're getting bigger. One thing you really have to be careful of is to make sure you use y for range and you use x for domain. If you mix up the variable, it will be counted wrong. Finally, you have to decide if this is a function or not. This does pass the vertical line test, so it is yes, a function. Moving on to number 13, you now have a shape that doesn't have any arrows. Instead, this starts at a point and then it stops at a point. So in order to determine your domain and range, you're still going to look left to right for domain, but you're basically just going to find your starting point and your stopping point. So I'm going to draw my x-axis above my graph. On the left, the farthest I move to the left is -3, and that is an open circle, which is important. The farthest I move to the right, the farthest x value is +2, and that is a closed circle. So watch very carefully how you're going to write this. As long as you always go left to right, since -3 is smaller than 2, we're going to put x in the middle because domain is always x. As long as you write this in the correct order, you don't have to necessarily worry about your inequality signs because -3 is less than 2. This is a fancy way of saying x is in between -3 and 2. The only thing we're now missing is that we need to underline this inequality sign because 2 had a closed circle. So we underline the inequality for closed circle, we don't underline the inequality for open circle. Same thing with the range, except for the range, remember, you're going to go from the bottom to the top. So for this one, we're starting at the bottom at -1, 2, 3, 4. We're stopping at the top at +3. Again, -4 is less than 3. Range is always y, so we use y instead of x. Since -4 is less than 3, I'm going to use less than signs. And then I'm going to underline -4 because -4 had a closed circle. 3 had an open circle. As long as you write this in the correct order with the smaller number on the left, you don't have to stress too much about your inequality signs. It'll always be less than because y is in between -4 and 3. Finally, we have to decide if this is a function. This one does pass the vertical line test, so it is a function. "14 looks really fancy because it is a shape, but it's actually very similar to number 13. It's still a function, or it's still a shape that starts at a point and stops at a point. So first, just looking at my domain, I'm going to find the starting point on the left, the stopping point on the right. For this shape, I'm starting on the left at negative 1, 2, 3, 4. I'm stopping on the right at positive 1, 2, 3, 4. So the way I'm going to write this, since this is domain, negative 4 is less than or equal to x, which is less than or equal to 4. X is in between negative 4 and 4. I went ahead and underlined these inequality signs because I did not have open circles here. Since it can actually equal negative 4 and positive 4, I'm going to go ahead and underline them. Now, looking at my range, I'm going from the bottom to the top. I'm starting on the bottom at negative 1, and then I'm going all the way to the top at positive 3. So negative 1 is less than or equal to y, which is less than or equal to 3. The last thing we need is to determine if this is a function or not. This does not pass the vertical line test. It crosses more than once, so this is not a function. All right, on this last problem, number 15, something was left off, so go ahead and draw arrows on the ends of these shapes. This was supposed to have arrows on it, and they didn't copy with it. So go ahead and draw arrows, and then let's talk about this. Even though these are disconnected, you're still going to look at this like you would any other shape. You're going to look at the farthest left and then the farthest right. So this parabola is eventually going left forever. This line is eventually going right forever. So my domain is going to be all real numbers. If you look right here, it looks like it, because you have that open circle, excuse me, at 2, 5, it looks like you wouldn't have all real numbers. But since you do have a value here at 2, 1, it's still considered all real numbers. It still hits positive 2. Same thing with the range. If you look here, this arrow is telling me that I'm going down forever, and then I'm going up forever. So my range is also all real numbers. Now, to determine if this is a function or not, if I were to try the vertical line test here, it looks like it might not pass because of these 2 points. However, since this is an open circle and this is a closed circle, it actually only uses the x value of 2 once, so we will consider this a function. Make sure you study all of the different types of graphs for domain and range, and then always remember that domain is left to right, range is bottom to top. That's the most important thing you can take away from this lesson.